Buenos dias. Just for a change, this morning we're going to talk about the speed of light. Okay, first up, another item of clothing. Okay, in the house, substantial amount of money. Nobody came for the socks I was parading about a week ago, orange and black socks. Today, don't know whose it is. It's been in the house for quite some time. I'm having it. Substantial amount of money. If I don't hear, it's just going to wear and tear. Okay, same as the socks. Speed of light. It is said that photons leave the sun traveling at 299,792 kilometers per second. Towards Earth, they take 8 minutes and 20 seconds to reach us. The sun has a diameter of 1,390,000 kilometers. An alleged, this is what they tell us, all right? I can't stress this enough. And the speed of light at 299,792 kilometers per second, if we divide the sun's diameter by the speed of light, we get the number 4.6. That's seconds. It takes the sun, because of its large diameter, 4.6 seconds to radiate its own light, the distance of its own, just a gentle tap this morning, of its own diameter. This number is ridiculous. It's an insult to people's intelligence. The sun in the sky, as I have pointed out on more than one occasion, when we have a close-up of the sun and it's taking up half of the screen space on the phone, it's taking 4.6 seconds for that sun to radiate its light to the other side of the phone. The distance of its diameter, 4.6 seconds. That's 1, 2, 3, 4, 6. A star. If the sun turned off for a while, for a period, cooled down, and we came back the following day and we said, right, switch her on, this is what would happen. All right? It's just switched on, it's been off for 24 hours for a refit. And here it goes. It's just cranking up. This is how fast it would radiate its light. The outer ring, the outer edge, is the one we're after. 3, 2, 1, go. 1 diameter. 2, 9.2 seconds. 3, 13.8 seconds. 4, and so on. Now, I was probably going a little bit too fast there. Right here are 2 lines. The distance from here to there are 6 of these sun diameters. 1, 2, 3, 4, 5, sorry. It is, look, it is 1, 2, 3, 4, 5, 6. 6 sun diameters. It would take this star, our sun, 27.6 seconds to radiate its light the distance of only 6 of its diameters. 27.6 seconds. There is no way that anybody can think this is normal. This is not an interstellar movie. This is real life. We are aware of this. This is it. If this is what would happen. There is no 4.6 seconds to be seen anywhere. Yeah, but it's a bulb. I will throw people off of the bus. A light source, a spherical light source, it isn't logical to think that it slows down as it gets bigger compared to a smaller version of itself. You cannot have a bulb radiating 100,000 plus diameters at the flick of a switch to then go to a light source the size of the sun and think it takes 4.6 seconds to then radiate light the distance of its diameter because of a Mickey Mouse speed of light involving photons that simply do not exist. We know this because during a solar eclipse, when the sun is directly behind the moon, so the moon is here and Earth is here, sweet spot shadow on Earth, and the sun is directly behind the moon. Common sense. There is no delay. It does not matter what you say. There is no delay, don't matter what you say. Kind of a thing. It really doesn't. You can get annoyed. You can put your heads in the sand like ostriches do. Not that I've ever seen one do that, but apparently they do. But they lie to us so much that who knows what they do. I was going to draw some pretty pictures, but decided to use the stuff we already have at hand. Now, every single star in the night sky, you're told, takes X amount of years to reach you because light is finite and it travels, doesn't it? The sun, is that the sun here? The sun, the closest star to us, not to scale obviously, takes 8 minutes and 20 seconds to radiate its light to planet Earth. It doesn't. It just doesn't, okay? Pick a star at random, somebody. That one? Which one? That one. Okay, that one. Doesn't matter what star it is, you're looking at it. Every single star on this thing here takes time to reach us. That is the sun, the closest one. The next closest one is Proxima Centauri, and we cannot see it for some reason. It is the next closest star to us, right? We cannot see it. We cannot see it because it is not powerful enough. All of the stars that we can see take maybe it's 4.2, 4.3 seconds. Then we have Barnard's at 5.6. And then look, anywhere between, you can pick however many light years you want. This one might be 25 light years. This one could be 36 light years. This one could be 42 light years. This one, and so on. There is not one single star in the night sky that you see straight away, apparently. Not even the sun, our closest star. It's all horseradish. If a star appears in the night sky, whether it be a supernova, a new star, any kind of light source, it doesn't matter how far away the star would be. If a star suddenly becomes visible one night and you're looking up there, bang, just like that, it means that you are seeing that star as it just turned on. Bang! It does not mean that that star is at such a distance from Earth, from us, that it's taken 2, 3, 4, 10, 20 years to reach the point there where it suddenly appears in the sky. Oh, there it is. We knew it was coming. Of course you didn't know it was coming. Nobody would know it was coming because light is absolute. There would be nobody to warn you that, oh, a supernova has just, how would they get the information here? Impossible. Impossible. If a star appears in the night sky, bang! That means you are seeing that star exactly where it is when it turned on, where it is doing what it's supposed to be doing, radiating absolute light. If a star, there could be a star right next to that one that lit up at the same time, but it's just not powerful enough. It doesn't matter how long you wait here for, that light will never rock up in the night sky because light does not travel like that. Light is absolute. It is not Mickey Mouse, finite. If another star lit up, that's how you would see it. Anything, any light source that you can see in the night sky, you are seeing it exactly where it is at, live. There is no delay. There is no delay anywhere to be seen. The methods claim to have worked this stuff out, starting with Roma in 1676. Rubbish. All of them. They don't even pass the pub test. Spinning mirrors. Parallax. No tools whatsoever. No instruments, nothing at all. But people believe that light is finite. People believe that the sun, which is shining on right now, if that sun turned off, we're looking at it there, and we are on planet Earth here, on this side, right? That sun turned off, being told that as it closes in on planet Earth, it would take 8 minutes and 20 seconds before planet Earth realized that the sun had turned off. It would take 8 minutes and 20 seconds. We wouldn't know that the sun had turned off, right? If it turned back on, it would take, I probably did that without zooming back out. If it switched back on, we wouldn't know for 8 minutes and 20 seconds. So look, let's do it over here. Here's planet Earth. Ignore that big sun. We're going to use our own sun. Here's planet Earth. Right? Now, let's just say the sun. Ignore all the other planets, okay? Just like they tried to make you ignore Pluto. The sun is this way. It turned on. 3, 2, 1, bang, sun is on. It will remain dark for 8 minutes and 20 seconds. And then the light will appear. 8 minutes and 20 seconds. It is an absurdity. It's ridiculous. There can be no light without a source. If the source goes out, the light that it's radiating will disappear at the same time. Doop, gone. It's not going to be a case of light source turns off and any light that was travelling away from that light source will carry on its vacation indefinitely. No, it's rubbish. It's absolute rubbish. How? What is propelling it? What is propelling it? Light is absolute. You cannot separate the light being radiated on a surface from the light source itself. If it turns off, it disappears. It does not matter what the distance. That is absolute light. There is nothing, a light year, no such thing as a light year. If you can see a star in the night sky, you're seeing it because it is powerful enough for you to see. All of these stars that you're seeing in the night sky, you're seeing them because they are powerful enough to be seen. That is why you see them. That is the most logical explanation you'll get for why you can see a star in the night sky. Because it is powerful enough to reach your eyesight. Your eyesight can pick the star up where it is. That is why you see them. You do not see any star that is not visible immediately, right from the onset. If a star is out of range, let's say there's a star here that lit up 2 years ago, big star, bright star, and so far away that if it didn't reach your eyesight the moment it turned on, that's it. It's not going to be a little beam of photons traveling towards your eyesight. It's ridiculous. It is ridiculous. All right. Cold last night, but I tell you what, man-made climate change, I think I can feel it cranking up again. So be wary out there. Well done to all of those people that have called man-made climate change, because you obviously know every single other variable there is to do with the climate. That's the only way you can call man-made climate change. You know absolutely everything. If you can call a difference of 0.01 degrees Celsius every year, that's what they're claiming, 1 degree over 100 years Celsius, right? Another insult to people's intelligence, folks. All right, happy weekend. And substantial amount of money. I like this one. Latest peeps. Happy weekend.